moving now onto the receive side of the Team TRX404 CEPT CB radio, and also enjoying a cup of tea in my CB2781 mug. I should have had a CPT mug for this radio. The first part of the receiver which we're going to look at is T1. Now I'll just zoom in on these. Got a relay here for the transmit and receive. I never like relays because they do have contact problems over a period of time, and then you find you can't get the relay out, you know, after years. However, it seems to be working on this radio at the moment. So transformer 1 is that one there, transformer 2 is that one there, transformer 3 is that one there. So we'll just see what we're receiving on the test equipment. Well, that's 1 microvolt, and that's very listenable to. So I've got this connected to the synod meter and subsequently an oscilloscope. So see what we can improve. Well, I have improved that. I'll just back the signal generator off. And improve again. In fact, I'm going to change scales to 0.3. We'll just go through these a second time with the camera on. Well, we've got, that's 0.3 scale. About 0.15 I can hear on that, which is very good sensitivity indeed. Now if we move over to the detector, you've got the MC3361 IF subsystem chip there, and next to it there to the right you've got T4, which is the detector. I'm going to put an S9 signal on. This time I've got an oscilloscope connected to the speaker output, and I'm looking for the maximum possible recovered audio in the form of a sine wave. Slight improvement there. You know, if the detector's out, it's going to sound so garbled it'll sound like one of Doctor Who's Daleks. So it's always important. That's what you need an FM signal generator for. I've been talking to 1 or 2 of the subscribers on YouTube who are going to be using some what they can afford second-hand test equipment, and I've said you can use an AM signal generator unmodulated to set up the sensitivity of the radio, if you're doing it by ear especially. You really need the FM signal generator when you're setting up the detector. But you know, you could get by, you could have one of those cheap walkie-talkies with the call tone on it, you know, those little 100 milliwatt ones. You could kind of hold that somewhere in your left hand and maximise the detector with your right hand doing that, looking at a scope. So it is doable on a budget, and I'll do a video on doing it on a budget. I'm going to gather together some dead cheap second-hand test equipment, and I'm going to show you how you do these on a budget. It's alright having laboratory test equipment, but not everybody is doing it commercially and can justify it or even afford it. I certainly couldn't afford to replace any of these instruments. Now, so right, forgotten where we are. Oh yes, we've done the receiver. Now then, what I'm going to do is I'm going to set the S meter, and the S meter is resistor 30. Resistor 30 is the preset which is under the selcall socket there at the side, which is just there. Now if I just tilt this up, let's see whether we can see. So that is, it's showing all the bars at the moment. Well, I don't want it to show all the bars. I want it to just be off the plus 30. Now when I increase the signal generator, hopefully... No. No, it won't set up how I want it to set up. So we'll just set it so it's just on. Now I'll just back off the signal generator. No, you can't set it out. You can't calibrate that. It's 3 and 4 are virtually identical in the way they are. Anyway, that's an S9 signal, and it's showing plus 30. Dropping it down, and that reads how you'd expect. So it's a visual indication, but you can't calibrate it too precisely. Right, we're going to check the squelch. So I'm dropping the signal generator off altogether, setting the squelch to threshold. Well, that wants some cleaner on it. Now we'll switch the signal generator back on. You know, it's coming at 0.3. That's incredibly sensitive squelch. I mean, it's helped by this radio having crystal filters. You know, it's really pin sharp. Let's go and advance the squelch to full. And now we'll advance the signal generator. Oh no, that's far too weak. That wouldn't squelch out anything. Resistor 118 is the squelch preset. That's the centre one of the three. No, I think that's a bit dirty, and that might be why the squelch, we're using the Servicell switch cleaner. Other countries will have other ones, but that's the one which I've used for 30-something years. What I've done is to set that to full. I'll tell you what, it still comes in at 3 microvolts, so it's what you'd call a bit of a weak squelch. So I'll just do my initial test. Set threshold. No, he's not having it, so back that off a bit. Squelch to full. Yeah, you're not going to get more than 3 microvolts out of that squelch. It's quite weak by what we would expect. Right, so that's covered the squelch, which it doesn't impress me. I'm not going to touch the third preset there, which is selcall sensitivity. Although we've got a selcall unit, I haven't got the service manual for how that's set up. I've got a good idea because I have worked on selcall on business radios, but we'll have a play with the selcall units another day. So just to recap, we've got on the receive sensitivity, we've got transformer 1, transformer 2, transformer 3. The detector there is transformer 4. The S meter set is the one under the selcall socket there, which is resistor 30, and the squelch preset, for what it's worth, is 118. And there you have it, a very sensitive set with a very weak squelch. Incidentally, these have a Roger bleep, just in case you've come across these before. And the switch here is to switch between selcall and normal. I'll come to that when we cover the cell call units. You've got Roger Bleep and you've got VSQ is the cell call select.